And we're live.
Yeah. Hello, everybody. We would like to make a short, or probably not so short, overview about the DAO, about the technical side of the DAO, and it's mainly intended for developers who will do a code review. There's Christoph and Chris on the Hangout, also they are intending to make a code review, a deep code review about the DAO. The code is still not complete, and it's still not really ready for code review, but we thought it's a good idea to start already to get a good introduction and a deep understanding about the whole concept and about their implementation details as well. Okay, I will make a screen sharing 1 second. So now, yeah, I think it's visible now. Okay, let's jump into it. We have a pretty tight agenda. I will give a short overview about everything. Just a disclaimer. I assume, or it's expected that the listeners know already about the DAO and, of course, about Bisq. So when you're completely new to Bisq or completely new to the Bisq DAO, please read up first the general overview documents available on the webpage. It's intended for people who have already a pretty good understanding about the Bisq DAO. Yeah, we'll give an overview, then talk about the different phases. Yeah, we'll talk about it later. Then the blockchain part, the peer-to-peer network part, the way how the blockchain gets passed to distinguish which are BSQ transactions, the threading model, the data model, the resilience of our different data sources, their activities in each cycle, and yeah, the code overview, then general challenges, next steps, yeah, how we go on. So overview. Yeah, we are using the Bitcoin blockchain for getting consistent data, and we are using as well the peer-to-peer network and the peer-to-peer network has eventual consistency. So this creates some challenges, and we have to deal with this. And I will give then later a little bit more explanation how these two different domains are linked together, that they work together, and of what we have to take care of. We use the peer-to-peer network for distributing the rich data. For instance, the proposal, it contains about all kinds of data like description, links, and so on. We cannot put this into the op return. That would be too much data. Even that was an early approach to do it, or at least the voting on the blockchain directly in the op return, but that would have been much more complicated and would have had other side effects. And yeah, we link the peer-to-peer network data with the transaction ID of a transaction, and so every like a proposal, when it gets published to the peer-to-peer network, it contains the transaction ID of the proposal transaction. So there's always a transaction, and then there is a peer-to-peer network data. Also, there are especially two such events where this happens. One is the publishing of the proposal, and one is the publishing of the voting, the blind voting. Also in voting, yeah, we are supporting earlier concepts. We had just a normal voting where it was visible immediately what people vote on, but that carried the problem that with late votes, so basically there was an incentive to wait until the last moment, and then when somebody has a lot of stake, he could be more influential in the last moment to vote. And now we have blind voting. So during the voting phase, the votes get published in an encrypted way, so nobody can read it, but they get timestamped on the blockchain, and then in another phase, the votes get revealed. And here again, we have a peer-to-peer network data, the blind vote data, which get published, which carries the transaction ID of the blind vote transaction. And on the Bitcoin side, we are using the op return and put the hash of the peer-to-peer network data into the op return. So we have from both sides a link to the other domain. Also on the Bitcoin side, when you look up the transaction, you can verify that a certain peer-to-peer network data is really the one which was used for this transaction by checking the hash. Yeah, we have different phases which are separated with breaks. The breaks are important for avoiding issues with reworks. the blockchain can be reorganized when there are competing chains at the same time, and to not get in troubles with such situations, we are using breaks between the phases, which are something like minimum 10 blocks. I think the deepest reorgs on the Bitcoin blockchain was something like 4 or 5 blocks. So with 10 blocks, we should be already super safe. Maybe we use even much more. And yeah, there are different phases. I will talk a little bit later about the phases. And as I said already, we use this blind voting to avoid this late voting problem. And we are supporting full nodes and light nodes. When normal users probably will run as a light node, where they get their filtered BSQ transactions from a full node, which is usually a seed node, but there can be a specialized node as well. But every node can run as well as a full node. When you run as a full node, it requires that you have Bitcoin Core locally running with a special setup for RPC. And then you are, from the Genesis transaction on, you are requesting all the blocks from Bitcoin, from your local Bitcoin Core client. And with all those blocks, you are verifying which transactions are BSQ transactions, and you're building up this filtered list of transactions yourself. The light node is also doing the full verification. It just gets the pre-filtered Bitcoin input, or that is Bitcoin transactions from a seed node. Also, when there are something like 2,000 transactions in one block, maybe we have then 2 or 5 or 10 BSQ transactions in one block, and the light node will receive those 5 transactions from a seed node. The full node is requesting all 2,000 transactions from a local Bitcoin Core node, and is passing all those, and then we'll find out that only 5 transactions were relevant for BSQ, and then stores locally those 5 transactions. As I said, there are different phases. The first phase is the proposal phase, which will take something like 3 weeks. All the phases are measured in blocks, so there is no other time in the system. But the rough time will be something like 3 weeks. All 4 phases will create one cycle. That's what we also use now. So every month we are doing new proposals and new compensation requests, and we stick with this. The duration of the phases will be changeable later. It will not be implemented immediately, but at least it's prepared that it could be changed. So when we find out that 1 month is not a good period. And then the second phase, after the proposal, there will be a break of a few blocks. Then there is the blind vote phase, and in the blind vote, every BSQ stakeholder can vote on proposals. So he, in the proposal phase, he collects all the proposals what people are publishing. The people who are publishing the proposals can also remove a proposal when they want to edit it, basically, or want to withdraw it. After the proposal phase, the proposals cannot be removed anymore, and the blind vote phase starts. And people can vote on the proposals what they have received, and can vote either with accept or decline when it's a compensation request, for instance, or when there are other items like changing a parameter in the DAO, like, for instance, the duration of phases or the amount of the trading fee. All those data will be subject for changing, and in the vote they can give their voice on that. Their data will be encrypted and published to the peer-to-peer network, so everybody can see that somebody has voted, as that there will be created a transaction as well, but nobody can read what has really been voted on. But the voter cannot change his vote anymore, because everything is hashed in their Bitcoin transaction. So it's basically timestamped what you have voted. Then after the blind vote, there is a break again, and the blind vote phase will take a few days, maybe 3-4 days, something like this. Then there is a short break again for the avoiding the reorg problems, and then there is the vote reveal phase, where everybody who has voted need to be online in this moment. It doesn't have to do anything actively. The application itself, when it recognizes that it's in the vote reveal phase, and it has not revealed already that it will create a transaction and send out this transaction to the Bitcoin network. There is no peer-to-peer network data in that phase. And this vote reveal transaction contains the secret key, which was used for encrypting the blind vote. So everybody can look up then from the blockchain data the secret key, and from that moment on can decrypt this blind vote. So when one voter has been online in this phase, he has published his transaction with the secret key, and all the other users will receive this and can decrypt this particular vote. And at the end of the phase, there will be the result phase. Again, after a break, in the result phase, every node is collecting all those blind vote transactions, will look up all the blind votes and the blind vote transactions, and then can decrypt the blind votes. And from the blind votes, they see the proposal, and they see, in the blind votes, they see also the what the user has voted on. So with the result, in the result phase, you have all the data available, and every node can calculate the total result of the voting. There will be a threshold for a quorum and for if a vote have succeeded or not. That will be different for different types of proposal. Like for compensation requests, usually it will be minimum 50%, or it need to be a little bit more like 50%. For other proposals like changing a parameter, it might be a higher threshold, like 70%. And there will be a quorum in BSQ, how much stake there have to, how much the stake in total is required that the vote is considered valid. So when a minority stakeholder was the only one who was interested in one proposal and has voted on this, it will not be accepted. Goody. And the blockchain, as I said already, we have 3 transactions. The proposal transaction. In the op return, we have the hash of the proposal payload. All those op return data carry also a type, also a byte for distinguishing these different transaction types, and a version. Then there is a blind vote transaction, where again the op return of this blind vote payload is in the hash of the blind vote payload is in the op return. And then there is the vote reveal transaction, where the secret key plus the hash of the blind vote list is in the op return. And this hash of the blind vote list is a little bit a tricky concept. Because the peer-to-peer network data have this eventual consistency, there's no guarantee that every user will receive all the proposals and all the blind votes. But when a user would have a different data view, and when one user only have received 9 out of 10 blind votes, another user has received all 10, they will come to a different result when they come to a result phase. So we have to be sure that everybody has exactly the same data view from what they're using for creating or calculating the result. And for generating a consistent and a well-defined data view, the voters themselves, when they're doing the reveal transaction, are doing a kind like voting on the majority data view. So every voter, when they are making the reveal transaction, they have received a certain number of blind vote data objects from the peer-to-peer network, and they put this into a list sorted by transaction ID and create a hash of this and put the hash into their reveal transaction. And with the stake or what they have voted on, we can find out what the majority of the voters, majority by stake, has seen in the network. So for instance, when there are 10 voters and one voter has only received 9 out of 10 blind vote data objects and the other have received all the 10, then the majority will be 10, the hash of the 10 blind vote data. And the one with the 9, when it comes to the result phase, he will discover that his hash, what he has locally, his data does not match with the majority, with the hash of the majority. So he see that he's in an invalid state basically and need to get this missing data. So he need then request from the peer-to-peer network that this missing blind vote and maybe proposal data. And as soon as he has all the data, he can also participate in the calculation of the result. So that's a little bit a tricky thing, and I'm not 100% sure if it was too fast to really understand it. We can discuss it later.
Huh? Oh, sorry. Yeah. Okay. Sorry. Shall I wait with the question until the end of the presentation?
No, you can interrupt me directly.
Okay. Sorry. I just wanted to ask regarding the reveal vote phase. So if one party doesn't send the reveal vote transaction, is there a problem for a system, or how this is handled?
The importance always starts from what's in the blockchain. So when you're calculating the result, you first look up which blind vote transactions are there, and from the blockchain the data are unique. There is no inconsistency. Everybody has the same blockchain data. So when you would not be online as a voter and would not create your vote reveal transaction, your vote is just invalid and will not be considered. When you would not have, well, when your peer-to-peer network data would not have been published because of bad network situations or whatever, and only the transaction would be there, then it's also invalid because in the next step you will look up for this peer-to-peer network data for the blind vote. And also that's in the blind vote because the revealed transaction doesn't have a peer-to-peer network data. There's only a transaction alone. But the revealed transaction, there's an important link between the blind vote transaction and reveal transaction. You are voting with stakes. So with you put in the blind vote transaction some BSQ into the transaction, and in the output of this blind vote transaction, this BSQ are locked for voting, and the reveal transaction is spending this locked BSQ and it's unlocked afterwards. And with this output from the blind vote transaction, which is the input for the reveal transaction, we have a clear link of those two transactions on the blockchain as well. So in a case where you have a blind vote transaction but no peer-to-peer network data, it's invalid again. And the same the other direction. I mean, you would not even consider a blind vote peer-to-peer network data when there is no transaction. You just ignore it because you first look up in which transactions are there on the blockchain, and then you look up for the peer-to-peer network data. And it's all verification is done there, that it's in the correct phase and in the correct cycle, and that all the rules of the DAO are correct, the transaction have the correct format, and the data and op return are expected, and and the blind vote data has a reference then to the proposals, and the same happens then with the proposals. There need to be the transaction, and there need to be the peer-to-peer network data, and only if everything is as expected, it's considered valid. Otherwise, it's ignored and it's not considered for the total result. So when there will be inconsistency, then it's just there is one vote less or one proposal less in the total result calculation. These inconsistency problems are more theoretical problems because we will add a lot of resilience that the publishing of those peer-to-peer network data will happen multiple times, and it will be very resilient. So I don't expect that in practice it will happen, but of course we have to deal with it, and especially could be an attack vector. A malicious peer could try to attack then the DAO by when there would be some weak point here that it would lead to inconsistency. That would be, of course, very bad. Is this more clear now?
Yeah, thanks. Yeah, I just want to ask if it's possible that one person can block the final voting phase or delay it as long. Okay.
The only open problem in a way, but we don't consider this as a problem we deal with, is a majority attack. So when the majority of the voters would sabotage the DAO or would attack the DAO by holding back the blind vote data. So let's say I'm the majority and I want to kill the DAO, then I could make a blind vote transaction with my own blind vote or peer-to-peer network data included, but I will not publish it. So nobody else has a chance to receive this data, and nobody else has a chance to get to the same hash. Or maybe a group of people are the majority stakeholder. They can create this majority data view. And then nobody can calculate the result because nobody has this blind vote data what I have not published. And with that, yeah, everybody would try to get this data. Nobody can get it because I will hold it back. And then it's an inconsistent state because nobody can calculate the result. But that's a majority attack. When the majority of the stakeholders want to kill the DAO or their own investment, okay, then they can do it. And somebody will fork the project and will take over. So it's a basic situation in the DAO when the majority of the stakeholders are evil and want to break the DAO. Yeah, they can do it, but the worst thing, what will happen probably is that somebody will fork it and will start over again, and they will render their investment and their stake are worthless. So it's not really rational to do this. And also by voting, and here also with the stake, at the moment we only use the stake, but in future it will use the reputation. So the more a stakeholder has earned really with contribution, the more influence he will have in voting. So we will have a different or a secondary influence factor for calculating the weight of the vote, which will be not only the stake, but which will be the issuance what the voter has created for himself. So yeah, when somebody has worked already 1 year for Bisq and has issued 100,000 BSQ for himself, then 100,000 BSQ will be a big part for his vote weight, and yeah, probably something like 70% comes from this reputation and only 30% comes from stake. So this majority attack will then be even more limited, that there's a whale with a lot of money who buy into the DAO cannot do so much harm. Only those who have really worked for the DAO, and then yeah, when they want to hurt it, then something is very strange probably. And I mean, with this majority data view, is this clear? Should I explain it a little bit more in detail, or a little bit slower? Maybe it was a little bit too fast. Maybe I go over it again. There could be this situation that that one voter was very badly connected with internet and his blind vote data was not spread in the network. So he himself sees his own blind vote data, but nobody else. So he, when he comes later then to the result phase, he has, for instance, 10 different blind vote transactions and data and proposals and so on. And he will have a different end result because maybe he rejected a proposal and he was just the influencing factor if a proposal got the 50% or not. And all the others have accepted it and will get a different result. So all the other in the network, which only have 9 blind vote data, will maybe get for a certain compensation request the result 49%, and this one guy have them 51%. And for him, he would issue BSQ, the other would not issue BSQ, so it would be inconsistent state. There would be basically 2 versions of the DAO which are not compatible. And to avoid such inconsistency, we need to assure that everybody has exactly the same data which are used for calculating the total result. And to achieve this, we use this this kind of voting, secondary voting on the data view. So every every voter, when they are creating their reveal transaction, they tell the world their which version of the data they have. So all the others have only 9 blind vote data, as a peer-to-peer network data, and create a hash from this list. And this one guy has 10, so he will get another different hash. And he put then this hash into the op return in the vote reveal transaction. The others do it as well. And on the blockchain side, we never have this problem with inconsistency because everybody has exactly the same view on the blockchain. The only risk on the blockchain side would be with reorgs. It could be in a reorg time that you are following the chain with this block, and the others are following a chain with another block, and this block contains a transaction and the other block not. So there could be theoretically a difference, but that's avoided with these breaks. So for before we are starting any important phase, we always wait a few blocks, so we don't have any reorgs problem, because the data what we are taking out of the transaction is already buried deep in the blockchain and it is not changed anymore. And because this hash is in the blockchain, we have a unique view what is the majority, what the majority of the voters have received from the peer-to-peer network, and that is then the correct data view which will be considered valid. And when you, as a node which is just doing which maybe have not been participating in the voting but only want to do the verification, then you need to have all this peer-to-peer network data which results in the same hash. If not, you have to request it from the network. And when you get it from the network, then everything is fine. And the only risk, as said, would be when the majority of the blind vote data would attack the peer-to-peer, the DAO, by withholding the blind vote data, but they have created the hash and nobody else could come to the same hash because they never get this peer-to-peer network data, then it would break. But that's a majority attack, and we don't handle this because that would be basically breaking everything. Is it a little bit more clear now?
Yeah, thanks.
Then I jump to the next part. The peer-to-peer network data. We covered already a lot of this. We have basically 2 data which are published to the peer-to-peer network. One is the proposal payload, and it contains I call it payload because they get always robbed in some messages and some other objects which are distributed in the peer-to-peer network. And payload is the name to keep it different from the proposal itself as a data object. It contains the transaction ID of the proposal transaction, the same with the blind vote. And as I said, for the vote reveal, we don't have a peer-to-peer network data. There's only the transaction where the secret key and the hash is in the op return. The secret key is quite small. I think it's 16 bytes, and the hash is 20 bytes. So it's not really a lot of data what we are putting in here. And it's not a lot of transactions. It's only the voters. So like in the current situation, we have around 10 contributors who are making requests and who are voting. So there would be 10 proposal transactions, and then 10 blind vote transactions, and then 10 reveal transactions. All the transactions have a fee attached beside the vote reveal that comes without fee. And the fee can be changed also. At the beginning it will be rather low, but it's good to have it as a kind of like a regulation element. When we get too much voters who are not really well informed about the DAO, we can increase the fee. Voting is a management function and not a democratic right. I mean, every stakeholder can vote, but it doesn't make sense when people are voting who don't know, who are not well informed about the DAO to make good decisions. The parsing of the blockchain. So a full node, as said before, we have a full node and a light node model. The security differences are similar, like with the SPV model. The light node model or the light node is trusting the full node, which is delivering him the filtered BSQ transactions, that he has not held back any BSQ transaction, but he's doing the full verification. So the worst thing what could happen is that the seed node is not sending some BSQ transaction, and then there will be a problem. But the light node will receive this from several. As at the beginning, we will use the seed nodes for this, for convenience and for performance reasons. But basically, it can be any specialized node. And of course, every user can run their own full node and can set up their own full node to connect to. So, but for convenience, most people probably will not do this. And they will receive this data from multiple nodes. So when one seed node would be compromised and would deliver a smaller subset of transactions, it will be discovered very quickly, and then the light node will start over again. And the full node runs Bitcoin Core with RPC setup. It iterates all the Bitcoin transactions and filters for the BSQ transactions. A BSQ transaction is a transaction which has any BSQ as input. So the only exception is the Genesis transaction, because there is of course no BSQ input, and then all the outputs of the Genesis transactions are potential inputs for new potential inputs for new BSQ transactions, and all the other relevant BSQ transactions, for instance, for paying the trading fee, they carry, they also have a BSQ as input. I think all those transactions have BSQ as input, and as well they have these special op return types where we can verify if a special transaction might be a BSQ transaction or not. So we are filtering basically the Bitcoin transactions with a small subset of the BSQ transactions, and we are storing this in our own data structure. And the light nodes are just receiving this filter block. So the only really difference is that the light node is doing this passing through all the transactions in the blockchain, and don't need to get all the transactions because that would be too heavy. And is doing the full verification, as said already.
Sorry, Manfred, and the Bisq client will be a light node. Did I understand this?
Yeah, by default it's a light node, but users can change this over program arguments or in the settings to connect as a full node, to run as a full node. Then they need to run Bitcoin Core and have this special RPC setup. So they need to edit the config file in Bitcoin Core. They are just requesting all transactions from any block from Bitcoin Core, and they get notified of new blocks. So when there is a new block arriving in the network, Bitcoin Core is sending a notification to the Bisq client. And the Bisq client is iterating the block and passing the block. There will be also snapshots that when you have already passed the state and you're restarting your application, you don't want to start over again from the very beginning, from the Genesis transaction. And we are creating snapshots, either every cycle, or can be defined what is the time frame for creating such snapshots. And the snapshots are basically making a snapshot of the mutual data of the whole DAO, and we'll use this as the next startup, so that you're not starting over again from the Genesis transaction. You're just starting from your latest version of the snapshot from this block height. And then when there are some new blocks in the meantime, you're passing the new blocks and you're changing the state. And when it comes to the next block height where when you come to the next block height where it's triggering a snapshot, you are persisting the next snapshot, and that will be used for the next startup. we're also shipping those snapshots in every release. So when a new user is downloading Bisq, he will have already the snapshot from the release date. And as we have usually releases every month, it's more or less maximum 1 month what he need to pass. I tested it. That's more or less 4,000 transactions and no, 4,000 blocks. Sorry. And with 4,000 blocks, it's hard to. I have not estimated it with more or less realistic data, but with more or less empty blocks, it takes a few seconds to verify the whole month. So it's not really, and it's only a one-time effort. It's basically when you're starting up Bisq after 1 month, it also takes on the Bitcoin side quite a lot, and it's a little bit heavy. For 1 or 2 minutes, you need to wait until you are synced. And we are adding a little bit of load here on the DAO side because for verifying all the blocks in the meantime, since the last snapshot, it will take a little bit of load, but it's not terribly bad. That brings us to the next topic with threading. In an earlier version, or just recently, I used a special thread for the parsing and for the RPC. But at the end, that led to or maybe I explain a little bit more the basics about the threading before getting to the problems. Also, the RPC part is really slow. With live data, so with real mainnet data, what I remembered, it was more or less 4 seconds for 1 block. And the slow thing is that there is no interface that you get all transactions for 1 block. You have to request every transaction with a single RPC call, and they carry overhead, and that makes it slow. There are usually 2,000 transactions in 1 block, so there are about 2,000 RPC calls for 1 block, and that slows everything down, and that's by magnitude slower like everything else. So the parsing is super fast, like the light node, which is receiving the already filtered transaction, only need to verify it. That's pretty fast, but the RPC calls are way too slow to make it in the user thread, and so we need a separate thread there. And we're using the user thread for parsing and for all the consensus relevant code. So we have a single-threaded model that gives us the benefit that code is much more simple and much more clear and much more solid. So consistency and correctness is the most important in the DAO. When we would have any situation where, because of threading issues or whatever, we would get a different state, in certain situations, it will break the DAO basically, or it will break at least for this user. This user will get a different view, a different result, and there will be inconsistency. So that's by far the most important thing, to have really 100% consistency and correctness. And performance, of course, is important, like the RPC we could not do on the user thread. But the parsing, if a node after 1 month, when he downloading Bisq after a release 1 month ago, and he needs maybe 4 seconds, where the application is a little bit slow because it's doing the parsing, I can live with this. That's not terribly bad in my opinion, and we can improve this in future. But I think it would be not the right decision at the moment to use a more risky model and risk that we are introducing consistency problems. And I had this earlier, just 1 week basically, I moved to this model, and before there was the parsing also in this RPC thread. And then we had, initially we had locks in this. There is one data structure which is holding the mutual data, like when a transaction gets banned, that's mutable data, and you need to read and you need to write this data, and that's. I think we lost somebody.
I think Chris might had to stop the call.
Yeah. Okay. Yeah. Let's continue now then. With the threading, when when I had it before with locks, and so it was just risky that there would be some vulnerability with from the threading side with inconsistency. And I tried all kind of strategies to get rid of this kind of like mutual data and try to replicate the data. First, I tried some similar approach like with Akka, that you always kind of copying the data to other layers, and the UI, the user thread world would only get always a replicated data view, and that's the UI thread is, or the user thread is only reading from the state. So it was not really critical, but at the end it was getting super complicated and slow and tricky. And then I tried out Akka as well, but I think Akka would not be the right model for this, because we don't want to have a system where you have all kind of independent nodes which are doing their stuff and are very not connected in a control perspective. They're very independent and parallel. That's not the use case what we have. We have a very clear flow of control, and the ordering of stuff what need to happen is completely clear defined and relevant. And at least it would have probably required a huge refactoring and different syncing with Akka, and we would not have solved. I think it would not have been the right solution as well. So at the end, I went back that I only use this one thread for the RPC calls. The RPC calls could be easily optimized when we would extend the RPC API on the Bitcoin side. That we would add a new call where we get all the transactions with one call for one block. Then we don't have 2,000 RPC calls, but only one. And it's probably, instead of 4-second RPC overhead, it's probably something like 0.2 seconds or something, or even faster. So that would be a very low-hanging fruit for huge improvement. And yeah, of course, in future it can be improved. So when somebody comes and thinks we should use a special thread for the parsing, and he's doing it in a 100% correct way, I'm not against it. I just want to lose another month or more and have at the end a model which is more vulnerable and maybe a little bit faster. It's also not clear how much you gain because threads has overhead and so on.
Yeah, we just have to release quite often, so we have no problem.
Yeah, and it's, I mean, it's also not 100% clear if we are running a light node by default, or if by default it's off and only when a user is using Bisq, he will become a light node. Because it doesn't, when somebody is not interested in BSQ at all and doesn't use it for trading fees, why should he do this work at all? So probably there will be kind of like a mode where you only start to become a light node when you're actively doing anything with BSQ. So it would not hurt the normal area. I mean, we would like that all our users are using BSQ for paying the trading fees. So at the end, it's not clear how we deal with this, but I think it's not a big deal. I mean, it would be maybe a little bit a problem when we would have no release for 3 months or 6 months, and then instead of 4 seconds, maybe it takes 1 minute to do the parsing, or a few 10 or 20 seconds. But even compared with Bitcoin J, I mean, when you have not started or when you're first downloading, or it's different. With Bitcoin J, it's more, when you have an old wallet and you have not used it for a few months and then you're starting it again, it's quite heavy for syncing because it needs to verify, to download quite a lot of data from the Bitcoin blockchain, and it can take also a few minutes where the app is under heavy load. So I think we don't add a lot of problem in that area. About the data model, there are basically 2 parts, an immutable part and a mutable part. I try to make everything immutable what's possible. So there is basic unit, also the main class for The data model is the state, or maybe we call it BSQ state or blockchain state or whatever. At the moment, it's called state, and it consists of a list of blocks. Every time when a new block arrives on the Bitcoin blockchain, it gets parsed and filtered for BSQ. And during the parsing, we are setting all kind of other mutual state in this state class, like for instance, unspent transaction output map. So yeah, there's a map of the unspent outputs when in this block one of the previous unspent transaction output was used as input for a BSQ transaction. It changes this map, and this unspent transaction output get removed, and a new one or several new ones get added. And the block itself contains a list of transactions. The transactions contains a lists of inputs and outputs. It's the same structure like in Bitcoin itself. And the block itself and all inside is immutable. So once a block is added, it cannot be changed. The lists are immutable lists and so on. Only the root level of the state data model is mutable, because we want to add new blocks. We cannot use a mutable list there. But once a block is added, it cannot be changed. It contains also the cycles. A cycle contains a list of phases. So one cycle is this 1 month, and the other phases are proposal, and then the voting, the blind voting, and the vote reveal, and then the result phase. And because the duration of a phase could be changed in future by voting, we have to keep this flexible. We cannot use just the enum, which is which is static. So we have the enum basically as a type value in the phase, and then the duration, which could be changed by voting. And then there is a ballot. A ballot is a collection of a proposal plus a vote. So when you are actively voting on one proposal, you are locally creating a ballot, and it collects the data what you have voted on a special proposal. So the proposals are wrapped in those ballots with your votes on that. When you're not voting, the vote is set to null. Otherwise, the vote has the value what you voted on. And the blind vote contains a encrypt that's not correct anymore here. I recently changed this, but I don't want to go into the details. But basically, it contains the encrypted list of the ballots. So what you have voted, and on which proposals you have voted what, which is expressed as the ballot object. The list of those ballots get encrypted and gets published to the peer-to-peer network. Then the mutable part, as said, the state has a linked list of blocks. That's basically like the Bitcoin blockchain. Then it has maps of mutable data, like the unspent transaction output, the burned fee, and there are several such data structures, and that get updated at the parsing. During the parsing, when you're parsing the inputs, you will see, okay, an input is now used in a BSQ output. So the input which were connected to a previously unspent transaction output get removed from this unspent transaction output map. And then when the output at the end are valid, the output get added, and so on. And as I said before, we are using snapshots which get persisted to disk to avoid that we rerun the whole validation all the time. It's basically the same like in Bitcoin. When you use Bitcoin Core, the first time you are validating everything, and it takes quite a while. But the next time you start it, you are not revalidating everything. You have a snapshot of this latest validation state, and only new data which have arrived in the meantime, new blocks get validated, but not the stuff that you have done already. But of course, you can always rerun it from the source. When you just delete the snapshot, there will be also a feature in the application that also those snapshots, what we are delivering, shipping with the code, you always can go to the very bottom and delete this and go back to the Genesis transaction, do everything yourself, and don't trust anybody. Yeah, and there is different resilience from the data sources. I think it's very important to understand well this special situation, what we have, what makes us different to a normal blockchain project, that we are combining two different data sources. One is the Bitcoin blockchain, and the Bitcoin blockchain has ultra high resilience. So basically we can trust that everything which is deep in the blockchain will not change. That's the promise of Bitcoin and the value of Bitcoin. Of course, that's also relative, because like with Ethereum, we see that history get rewritten, and theoretically it could happen in Bitcoin as well, or with some altcoins it happens probably much easier and more often, that yeah, you cannot trust that this data will be really stored forever and will not change. But with Bitcoin we have ultra high resilience. And the peer-to-peer network, like the proposals and the blind votes, they get distributed over the peer-to-peer network, and we need to be sure that this data arrives and is available everywhere. We have this special mechanism with this majority hash to make sure that it doesn't cause a problem. But of course, when only 20% of the votes arrive at their peers, it would be also pretty bad, because people want to vote on all the proposals and not only on a small subset. But luckily, the peer-to-peer network is very stable. The only problem what we had so far was related to the Tor network issues a few months ago. But even there, it was not terribly bad. It was, yeah, there was issues, but and we'll add extra resilience here, that we are publishing, or for instance, at every startup, when you create a proposal, every time when you are starting up, you're republishing your proposals again. In the blind vote phase, when you vote on a certain set of proposals, or all the proposals what you see, you are republishing those proposals. So it will be we will add a lot of resilience, and in practice I think we will not have inconsistency, but of course we have to deal with this. And as I said before, the blind votes get decrypted from the key in the revealed vote transaction. And yeah, the blind votes are containing the ballots. The ballots contain I mean, that's not super correct anymore, because that I wrote with the little bit older version a few days ago, where I really encrypted the whole ballot list into the blind vote. But then we would have basically published, we would create too much data, because when there are 10 proposals and 10 voters, then every blind vote would contain all the 10 proposals, and then we would have in the network 100 times the proposals. We only needed 10 times, not 100 times. Now I changed this, that only the transaction ID is in the blind vote list, and the lookup for the proposal is done separately, and it scales much better in that way. But yeah, from the conceptual side, a blind vote is containing the ballots, the ballot is containing the proposal plus the vote, and the blind vote get decrypted from the reveal vote transaction. So yeah, there are several different activities in a cycle. It's a little bit so kind of like the basic use cases for every cycle. In the proposal cycle, in proposal phase, sorry, not cycle, anybody can make a proposal. They are publishing the proposal transaction. They are publishing the proposal payload to the peer-to-peer network. And at the same time, they are receiving all kind of proposals from the peer-to-peer network, and they are storing it locally. The one who has created a proposal can remove his own proposal as long as he is in the proposal phase. As soon the proposal phase is over, he cannot remove it anymore. Then when we're entering the blind vote phase, similar happens with the blind vote. You select, you have a list of the proposals, you select the proposals and vote on every proposal. When you're finished, or when you think, okay, I'm fine, I voted on everything, then you create the blind vote transaction, and you're publishing your list of ballots to the peer-to-peer network. At the same time, you are receiving those blind votes from the peer-to-peer network, and you're storing it locally. I just add in another thing here, that at the moment when you are publishing your blind vote to the peer-to-peer network, you're also republishing all the proposals you have used in your blind vote. For one thing, to add more resilience, and the other thing is that I separate now the storage of the proposals and of the blind votes in one data structure, which is protected by a public key, and where the creator could remove the data, like the proposals. It's similar like an offer. You want to be sure that nobody else can manipulate your offer, what you have created. So when you create the offer, you are the only one who can remove the offer. The same with the proposal. When you are creating a proposal, you are the only one who can remove the proposal. Additionally, what's not used in the offers, because the offers are only held in memory, they are not persisted locally. And that's not required because they are short-living objects, and we don't actually want to have offers which are not live. But with proposals, yeah, they live for 3 or 4 weeks during the proposal phase. And we want to have more resilience, that proposals are really 100% available. For this reason, we are persisting those data as well. But as you could remove this data, they are not super reliable. So we don't want to rely on this data structure. Also in the first moment in the proposal phase, we are just storing it in the peer-to-peer network data structures, but we are not really using those data for important stuff later, for calculating the result. But when we're entering the blind vote phase, the use case for removing a proposal is not valid anymore. So the guy who is, but we have no guarantee that the proposal owner is still online. Maybe he was just one time online when creating the proposal and goes online again at the end of the result. So we cannot rely. We cannot rely that he will republish his proposal in a secure data structure. So the voters are doing this, and because every voter will publish all the proposals what they have, there will be a high redundancy, and this data now will not carry the public key and is not protected by a signature, because there is no use case for removing this data, and for just adding it to a local data structure, the hash of the data is enough, because when anybody would manipulate this data, it would result in a different hash, and would be a different data object. So when you are publishing as a voter all your proposals, this data will get stored in a map where the key is the hash of the payload, and the value is the payload. And this is a append-only data structure. It's similar to what we are using for the trade statistics and for account witness data. But I just separated this, that we are not merging with the other domains. So there will be our own data file for this, for the proposals, and then later for the blind votes. And that will be then a kind of like a immutable data structure which can be only appended in a certain phase. And then it's frozen and cannot be changed anymore. Oh, sorry, it can be appended anytime, but you cannot remove data from this. When we are entering the vote reveal phase, we are publishing the vote reveal transaction. That doesn't contain any peer-to-peer network stuff. And when we are entering, and the application is doing this by itself, so the user don't need to do anything. Important for the user is that he get unlocked his stake. So when he's voting, he has locked his stake, what he was using for voting. When he would spend this stake, it would render his vote invalid. The application doesn't allow that he spent the stake, but when he would manipulate the application, he could do it theoretically. but it would render the vote illegal. And then after the vote reveal phase will also be maybe 2 or 3 days. The only requirement is that the voters need to be online in this time. So of course we need to communicate as well in the application that they know about it, but they only need to start up once, and once they are connected to the peer-to-peer network, they can shut down again. When entering the result phase, the application is calculating the result. That happens also automatically without user interaction. And yeah, they're taking all the reveal transactions, then all the blind vote transactions. From the reveal transaction, there is the connection to the blind vote transaction because it uses the output of the stake. Also, one input for the reveal transaction will be the output where the user has put the stake for the vote on this. That must lead to the correct blind vote transaction. And from there, we have the hash to the blind vote data, and the blind vote data contains the proposals. We can look up then the proposal transaction, and the proposal transaction has the hash of the proposal data, and we know the proposal. And we, in the blind vote in the decrypted blind vote data, we have the votes, and we have all the data basically to calculate the total result. We are checking if we have all blind votes which have been used for creating this hash, what the majority have seen. If, as said before, if we would not have it, we need to request missing data from the peer-to-peer network. And we're calculating the result. That's already all covered. I made here a small drawing about the phases. As said at the beginning, just a recap what I said already, but maybe visually it's a little bit easier to follow. I will show afterwards in the application it's a little bit more concrete. We have this proposal phase where people are doing, where we have basically three use cases. One is creating a proposal, another is removing a proposal, and the other is receiving or collecting proposals from the network. And creating a proposal has two different actions. One is creating the proposal transaction to the blockchain, to the Bitcoin network, and one is creating the proposal payload to the peer-to-peer network. Then we're entering, after the break, the blind vote phase. Here it's similar. We are creating a blind vote with two actions. One is the blind vote transaction, and one is the publishing of the blind vote payload. And we are receiving blind vote payload from the peer-to-peer network. There is no use case or no feature for removing a blind vote. Theoretically, we could, and maybe at some point we will allow it, that you basically could change your mind and you can make one vote invalid and vote again. At the moment we will not support this, but it's a possible feature in future. So it's all built in the way that it could support it. And then and at the moment when you are publishing your blind vote payload, you are republishing all your proposals, and then it gets stored in a different data structure. Before, the proposals in the peer-to-peer network was stored in this data structure, which is protected by the public key, and where you could remove data as well. And this removal would be a problem for later. For instance, when after a few months somebody would remove a proposal from the peer-to-peer network and from all the clients, this proposal or this blind vote would have been removed, then you cannot calculate the consensus anymore because some important data is missing. So it's really important that we are taking care that important data source for the consensus is immutable, stored somewhere, and the Bitcoin part is delegated to the Bitcoin network, and the peer-to-peer network part is consisting of those proposals and the blind votes. And as said before, we are using now this append-only data structure where there is no technical ability to remove data from there. And you are adding, as a voter, you are adding all your proposals to this data structure at the moment when you are creating your blind vote payload. And of course, because when somebody else has the same proposals, it will result in the same hash. So there will not be duplications of this data, but we get very high resilience when you have only 9 out of 10 proposals and the other peers have all 10, then the missing one will get added to the network by maybe 9 other voters. So it's a very low probability that some data is missing. Then we're entering the reveal phase. There we are only creating this reveal transaction where we are revealing the secret key and doing this kind of like voting on the data view, putting the hash of our blind vote payloads into the transaction. At the same time, we are here publishing all the blind votes what we have received. Also with the blind votes, it's the same in the blind vote phase itself. The data are collected in this data structure in the peer-to-peer network, which is protected by the public key and where you theoretically could remove it. So there's no API to remove it for the DAO, but a malicious user could do it technically. And to avoid that there are issues at the reveal transaction, at the reveal phase, we are republishing those blind vote data into this append-only data structure where the data cannot be removed anymore. And then at the end of when we're entering the result phase, you have all the data available. You are collecting all the peer-to-peer network data only from this append-only data structures. So you can be sure that data cannot have been removed anymore. And and then everybody has to get exactly the same result. And then you're applying the result. For instance, when there is a parameter change in the DAO, like changing the duration of a phase, or changing the fee for the voting, or changing the fee for trading fee, those, when it gets accepted and get a majority, it will become valid in the next cycle. So after at the first block of the next proposal phase, those new values get applied. And for instance, when the fee for the proposal has been changed, it would render a client who would have the old data view, who would not have applied this result, would use the old fee and would have invalid proposal. So of course, it's very important that that you cannot skip this result phase, and that you're applying the result to the new state and are building everything on top of this. And the same for the issuance. At the result phase, the issuance happens, and with the next block, because it requires a block confirmation, this new BSQ are issued and can be used. I mean, there will be a maturity maturity time, so you cannot spend immediately your freshly issued BSQ, but that's a detail. Yeah, maybe I make a quick switch to the. I have to switch the screen sharing. 1 second.
Yeah, really, really interesting stuff, Manfred. I'm really curious when we can try this out on testnet for the first time.
Yeah, actually, you can try it already. So basically, it's already working. I will make a quick demo. I think you see it now. Maybe I make no, it should work. I think there's some issue that some pop-ups will not be, or some drop-down menus will not be displayed in the screen sharing. Yeah, here we see the different phases for development. I made the phases very short, just 2 blocks, but in reality there will be a lot of blocks for a proposal, and then break something like 10 blocks or maybe half a day, then the voting for 3 days or 4 days, and then another break, and then the reveal maybe 2 days, and then the result actually only need to be 1 block, because it's only 1 block where the application triggers the result, and then it will be applied. Yeah, now we are in the proposal phase. So I can create a proposal. Let's say the other are not implemented yet, so I create a compensation request. I think that's not visible probably at this pop-up. When I click here, the combo box, I see the compensation request, generic proposal. Generic proposal can be any free text thing, like Bisq should implement Lightning Network, but it's only kind of like intention and people can vote on this. It has no really direct consequences. And then there are proposals for changing a parameter in the DAO, like the fee for the proposal or like the duration for the compensation request phase or whatever. And another type will be for removing an altcoin when, yeah, for whatever reason, there is one coin and the Bisq community thinks that's a scam coin. They can make a proposal for removing this altcoin, and when it gets majority, it will be removed automatically for all the users, because yeah, they will verify this data when it comes to the result that the majority of stakeholders don't want this altcoin in Bisq, then it will not be listed anymore in the viewer. So technically it's still in the code, but the users don't see this altcoin anymore. And so that's all basically kind of like smart contracts. So that will be all executed automatically without any external interaction and yeah, any extra requirement. The only thing is the generic proposals will require, of course, yeah, when Lightning Network will not be implemented by a smart contract, that's a lot of development effort. Yeah, you're creating your proposal with the form where you do enter your name, your title, description, a link to the GitHub page or wherever in the forum where you have more details, the amount, what you want to request, and the BSQ address where you want to receive it. Then create a proposal. You see a confirmation pop-up, but you don't see it in the screen sharing. And now in the active proposals, I see the proposal already. It's not confirmed yet, but I see all the data here. And I have Bitcoin Core running, so I can create new blocks on the fly. I create one new block, so I'm jumping to the next phase. So the second block in my very short proposal phase. Now I'm entering the break. With the break, we will now see, before there was a remove button. Now the remove button is away. You cannot remove it anymore, and you cannot do anything. You just can read it. Now we are entering the voting phase, the blind voting phase. And now we can, when we select, there will be a list of proposals. You can select any proposal, and you can vote on any proposal by accepting or rejecting, or when it's a proposal for a parameter change, there will be data fields where you can set the amount of the fee, what you think should be the amount for the trade fee or whatever. And let's accept this proposal. It's accepted. And now I could go on with voting on several other proposals, or ignore. When I'm not voting on a proposal, it's simply ignored. And then I will define the stake, what I want to use for my vote. Let's say I vote with 1000 BSQ. And now I'm creating this blind vote transaction and publishing the data to the peer-to-peer network. We will see it here in the wallet. Before, in the beginning, we have created the compensation request transaction. 1 second. I think there is a bug here. Yeah, there's a new bug I have not seen before. Here should be -1 because the fee for a compensation request is 1 BSQ at the moment, but it displays 14,000. That's some bug. But yeah, now I created this blind vote transaction. It's not confirmed yet, so we don't know about the state. It's not passed. So I create a new block on Bitcoin Core on the reg test. Now we know it's a blind vote transaction, so it's a fee for the blind vote were 2 BSQ, and we see also that we have locked the BSQ for voting. We see this here in the dashboard. 1000 BSQ is now locked. We cannot access this.
Manfred, one question regarding the mining fees, which has to be paid for the Bitcoin transaction. Is this kind of transparent to the user using it?
Yeah, so from usability, there need to be done a lot. Of course, it's very basic at the moment, but you will see all those transactions in the Bitcoin wallet as well. Like here, transaction fee payment for BSQ transaction, because for every BSQ transaction, you need to add some Bitcoin for the mining fee, because you don't want to waste your expensive BSQ for giving it to miners. And so, yeah, that's always reflected here as well. And yeah, it will get always a tag and maybe some extra link with a pop-up there. You see the connection to the action on the DAO side. But at the moment, that's all very basic. Yeah.
Okay. Yeah. Thanks. Just wanted to ask.
Oh, the UI is still, yeah, it's just a very basic that I can do quickly my tests of the basic use cases. But as soon as the data and the core is ready for a code review, basically, I will go on with improving the UI and implementing the missing stuff. Yeah, then I create also we are now exiting the voting phase. We're in the break, and now we are entering the reveal phase. And by entering the reveal phase, we have created a new transaction. That's the reveal transaction. With the next block, we get it confirmed. And we see there is no fee attached, so it has 0 amount spent or received. And yeah, this type's always here. You don't see this in the in the screen sharing, but these icons, yeah, are different for the different types. There are compensation requests, the blind vote, and now the reveal. And the reveal transaction is containing the secret key. So now we can decrypt the blind vote from this voter. And now we're in the break, and with the next we will enter the result. I will show it here, and with the result we are issuing our BSQ from our compensation request. So watch here, because it's only visible here because we are not creating a new transaction. It has only changed the icon to a $sign and changed the name here to issuance, because the output of the compensation request transaction was reserved for an issuance. So you as the proposal maker, you are putting in some Bitcoin, which is required for this amount of BSQ what you want to issue. Let's say you are issuing 10,000 BSQ, which are 1 million Satoshi. So you need to have Bitcoin. You need to have a Bitcoin input which has the value of 1 million Satoshi in Bitcoin, and you create an output which is 1 million Satoshi or 100,000 BSQ, 10,000 BSQ. And during the whole phase before the result, that's just a Bitcoin output. It's not considered BSQ because it has not been accepted yet. But after the voting, when your compensation request has been accepted by the network, this output now becomes will get interpreted as a BSQ output, and it's basically a new mini Genesis transaction where you have the authorization from the network that you can print new BSQ out from this Bitcoin, from this million Satoshi what you have put in, and 10,000 BSQ will have much more value, like this 1 million Bitcoin, 1 million Satoshi in Bitcoin. So you have created value. Yeah, that's it basically. And of course, the close after this phase, this proposal will move then to now we are in the next cycle, and this proposal is in the closed, and you cannot do anything just for viewing it.
Yeah, cool. Yeah, thank you so much, Manfred, for showing us the demo and also the detailed introduction on the Bisq DAO. Of those who are watching us live, are there any questions regarding what Manfred presented? Just to give them a chance.
Yeah, good idea.
Yeah, so if you're watching the recording and you have any questions, please just post your questions in the comments below, and we'll try to answer them as soon as possible. Or you can, of course, always talk to us and to Manfred in the Slack channel as well. Yeah, I think we don't have any questions in the live chat. So Manfred, feel free to continue.
Yeah, I hope it's not getting too much. It's a little bit dense, everything, I know, but we are nearly at the end. We're getting closer to the end. I would like to give a little bit of overview about the code structure. I don't want to get too deep into it because it's still under heavy development, basically, and I'm changing everyday stuff. Just to give a rough overview and idea, and I think the screenshots are already not valid anymore. But when you in the core project, you have a DAO package. It contains of the node, which contains then the parsing and the blockchain stuff and so on, and the state, which contains the data model, like the blockchain data and the cycles, and the voting, which contains the proposals and all voting related stuff, and then a few root classes like the choose module and setup and so on. So just a quick overview about the node package. It contains a full node for the full node and for the light node, different versions for the parser and for this node, which is the node is using the RPC service for getting the data. The light node is receiving the data over the peer-to-peer network from the seed node. Then during the parsing, we're doing all kind of validation. If a BSQ transaction is valid, that's split up in many different small classes where every validation class is just doing the stuff on their domain, like transaction output validator or transaction validator or input validator or iterator and so on. And yeah, then there's a state package. It contains the blockchain data, which is the block, the transaction, input, output, that basically a reflection of the data structure in Bitcoin. And then the periods, which is basically a cycle, which is this whole month cycle, which contains of a list of DAO phases. And every phase has a duration and a type, a name or enum. And the state class is the root for carrying all this mutable state. And as I said before, inside of the mutable state, there is immutable data, like the list of blocks contains only immutable blocks, and the block contains immutable transactions and so on. And there's a snapshot manager, which is responsible for making and applying the snapshots, and the state service is the access class where you're writing and reading from the state. Then there's the voting. There is the proposal. We have several different sub classes for proposal, like a compensation request proposal, or a generic proposal, or a remove altcoin proposal, or a change parameter proposal. Then there is the ballot, which contains a proposal and a vote. For the vote, we have Boolean votes, which is just yes, no, or parameter value vote, which contains a long value. And with you're setting a new value for the trading fee, that's the Satoshis as long value. And there is the blind vote, there is the vote reveal, and the vote result. And the vote result, you're doing all this verification and your calculation, and you're storing in special data structure your result data. And then there is a little bit more local data, like my vote, where you can you want to distinguish a little bit what's like your proposal and what's a proposal what you have received from the other nodes, but that's not very relevant. As said before, it's still I'm pretty close already to get to a kind of like a state where I say, okay, I'm on my side, it's okay now for a code review. There are still a few things what I want to change, and I would like to implement also, at least on a prototype level, those other use cases, like changing a parameter and removing an altcoin, just to have it bulletproof that we can implement it in future, even if it will not be part of the first release. I want to have it kind of like working and be sure that there are no surprises there. So that will take probably a few days as well to get this in. At the moment, I'm improving and refactoring this way how this data are stored in this append-only data structures. And yeah. So what are the important stuff of the DAO and the challenges? We have to be super, and that's why I really would like to get deep code reviews from several people. At the moment, there is SQ working with me on the DAO, so he's a great input for rethinking and thinking carefully about all the details, but the more eyes are on it, the better. And I would like to, after we have internal code review and we are basically as Bisq kind of like say, okay, we are okay now, I would like to get the external code review, maybe hopefully from Peter Todd or somebody similar. But yeah, we'll need to see how much this costs and if this person will be available. What are the challenges? Yeah, we need to be very careful about our fundamental design decisions and what cannot be changed in future. So there are, yeah, for instance, one design decision is that we have these phases relatively fixed. They can be changed by duration, but it will take one voting cycle. You cannot just say, okay, I want to have, there's something really important and we want to react very quickly. We want to make a quick vote and in 2 days we have the result. That's not supported in the basic concept, and that will be very hard to change. I mean, we could reduce the duration a lot and make this cycle as short as maybe 1 week, but at least there is some lower limit because you need to be sure that everybody gets online. You need to have this minimum blocks for the breaks and so on. You cannot make a cycle like 5 hours or 1 hour. Also, that's for sure a fundamental design decision. What cannot be changed in future will render a completely different concept and will change everything. There are, from the data structures, the immutable data structure probably cannot be changed. Maybe they can be extended. I'm not 100% sure. But there, yeah, as you mentioned, it's tricky to. It's a little bit like in Bitcoin. Also, this fine line, what is a soft fork, what is a hard fork, what you can change and what does not break compatibility or consensus. It's a very complex area, and there might be some areas where we could add new data fields, for instance, and new features, and then only update it. Clients will process this data because we have versions in every transaction, every area we are supporting versions, so we could deal with it when it's this version, then apply these rules, and when it's a newer version, then apply that rule. But we need to be sure that everybody comes to the same result still. So when it's a rule change or a new feature which creates new results, and these results are important for the DAO, then yeah, it will probably break consensus for nodes which have not updated, which is also not as critical like in Bitcoin. We can say, okay, when you want to use BSQ, you have to update to the latest version, at least at a certain point. We don't want to force the people that everybody has to update immediately, but we can say after half a year or a year that old versions are now not supported anymore. When you are using this, you get the invalid state and you get notified in the UI that you are basically on the old version and your view on the data is not correct anymore. And yeah, another question is how narrow we should define the rules. A lot of detailed decisions, what I do usually during coding, which also not all documented in the spec. Sorry. For instance, one decision is that theoretically in Bitcoin you could make several op return outputs. So it would be accepted from the consensus rules. It will be non-standard, so usually it doesn't happen because no node will relay such transactions, but you could create a transaction with 2 outputs, op return outputs. I'm not sure if you could put a value in the op return output. I think so. I'm not 100% sure. But yeah, we have defined the rule. There must be only 1 op return output, and the amount in the op return must be 0. So that's a more or less arbitrary rule because it doesn't really have influence in the Bisq system. But I just want to make it as easy as possible for verifying everything. And the more possibilities, yeah, the more special cases you have to deal, and the more attack vectors we would have. Like, for instance, when there would be 2 op returns, and one would be a correct one, what expected in the Bisq DAO, like a compensation request op return type and so on, and the other not. Yeah, you have to make the decision to. You have to do some extra work, and you have to. I just thought it's more safe for the DAO to be as narrow as possible, and render every transaction invalid, which is doing something which is which is defined by us to not be supported. It's a question if that's a good idea or not, because there might be some use cases where it could help us theoretically with the op return, when it would not be this problem that it would be non-standard. Yeah, we could. Maybe there is a use case where we want to put more data into the blockchain, and we need a second op return to put more data in. And yeah, at the current rule, we cannot do this. So it's a question if it's really good to make it too narrow, and maybe before we go live, we should reconsider it and make it a little bit more flexible and analyze it more if a certain rule can add some risk or not. Like supporting multiple op returns probably will not add really risk, but at the moment I'm as narrow as possible. Yeah, we have to think about scalability and performance issues. The big data in the peer-to-peer network are only the proposals, because yeah, they're containing this description and strings. All the other data is basically quite small. The data which are protected by a public key are in the time when they can be removed, like in the proposal time period. Then the data is quite big because the public key is big, but that's only temporary data that will be removed from the proposal maker the next time when he's online, and when he's out of the proposal phase or in the next cycle, he will remove his own proposal from this data structure. We could also prune it, this data. So, but yeah, basically I don't see a problem there. But yeah, and in this append-only data structure, this data will be stored forever. It's like the Bitcoin blockchain. And there we would have scalability issues when the data will become really big. But I think realistically, we have maybe between 10 and 50 proposals and 10 and 50 voters per month. We will not have 100, or so I assume that will render management very difficult when you have 100 proposals to vote on. But just to calculate simply, with 10 proposals and 10 voters in 10 months, roughly 1 year, you would have 300 kilobytes on data from the proposals, which is not critical. So we're adding basically 300 kilobytes as local data storage per year. With 100 proposals and 100 blind votes, it would be 3 megabytes. Also not a big deal, but might become slowly a little bit more problematic. But I think 100 proposals is already then probably we need to increase the fee that we get less proposals, or partition the DAO in several smaller projects, because I think it's from the management aspect already too large then. But of course, everything, yeah, or the performance, what I said before with the verification, I had done tests in early days with using mainnet data, and to catch up with the mainnet block data for a full node, it takes a while, a few hours. For a month, for instance, I think it takes half a day or so, but that's not a big deal. It's like with the Bitcoin blockchain, where when you need to catch up a few months or so, it's much faster now with new versions of Bitcoin Core, but a few years ago it was also super slow. And and nobody is forced to use those who are running full nodes, I think they will take this extra cost. And there is a lot of improvement possibilities there. So, but of course, has to be considered that we're not getting into real problems. In the code, it's already kind of like isolated a little bit, the consensus critical part, but that I will do even more and make it more clear that everything which is relevant for building consensus will be kind of like very clear, visible, and basically you cannot change those classes, you cannot change, you should not touch this code. And other parts are more, less critical, like which are just collecting data for displaying it in the UI or whatever. One open question where I'm not very sure is if we should use the protobuffer data structures or encoding for consensus relevant areas. Like we are creating these hashes which are defining the majority of the data view by using the list of blind votes and creating a protobuffer object out of it, serializing it basically, and taking the bytes from that. I'm not sure if it's really good to use protobuffer here. We're a little bit dependent I'm not sure if it's realistically possible that Google could change their encoding versions or rules of protobuffer, and it would basically break, would render a different byte result, or if there are some ambiguity, similar like with the signatures, that you can create two different signatures, transaction malleability topic. And maybe there is something in protobuffer as well, where you could get a different hash with two different types of, when there would be any risk there. An alternative would be to transfer it to a JSON object, would add a little bit of effort because we have already all the data structure for protobuffer, and then you have extra conversion to JSON or to build our own binary data structures, which probably doesn't really make sense, I think. But that's an open question. The way how we are flexible with updates and extensions, I said already, we have version bytes for all important stuff. So that should give us some flexibility, but we have to be, we have basically to count that what we are doing now will not be changed at least for 1 year. And when it will be changed, it might be a pain or might require kind of like a hard fork. And we should think about worst case scenarios, protection firewalls. What happens when there is a critical bug and the network, the consensus would have two different versions? What if somebody find out a weak area and exploit this? And in the concept, in the basic DAO concepts, there are already a few ideas, like to have a limit what can be issued per month, a hard limit in the code. So when a hacker find a bug and would exploit and would create 1 million BSQ, would not be allowed because there will be a limit of maybe 500,000 or whatever, and then it's the maximum damage what can be done. We also will define clear rules how we deal with bugs, not like the DAO that code is law, and then when their code was buggy, this doesn't is not valid anymore. We will, that's also in the concept already defined. We make clear when there is a exploit, we will try to fix it, and when there is a possibility, we will freeze this funds and we will lock it. We will have some peer-to-peer network messages where we can lock trading, and where we can signal to the network some emergency events, and whatever. I think we should think carefully about all possible worst case scenarios and how can we deal with it. Because I mean, when we fuck up the DAO, it can be the death of the project itself, and it can be really. We've seen it. What the DAO has created the damage for Ethereum, and we don't want to run in any. We don't want to get in this danger zone. The next steps. I hope that I'm getting ready for this first internal code review in the next few days. I mean, I'm only looking for developers for making a code review who really have enough time to get really deep into it and read all the documents and really understand everything, I don't want to have a broader code review with newcomers who don't know well Bisq and the peer-to-peer network and everything. I don't have time to onboard, and it doesn't make sense. Yeah, it should be only really a very in-depth code review of people who already know everything very, very well. And it has to be very carefully. So yeah, it's the most complex and the most dangerous part of Bisq, and we have to be absolutely sure that there is no that everything is perfect, and there are no. I mean, there might not be everything perfect on the engineering side, also like with the threading and so on, but that can be changed. But on the conceptual and on the consensus part and correctness part, everything has to be perfect. We cannot allow here weekend ambiguity. So I would like to focus first on more the conceptual, the design, consensus elements. Also, there are not many tests. They're not everything perfectly validated. At the moment, I'm doing too much validation repeated all the time. That's also on my to-do list to improve. And engineering improvements, yeah, to refactor just technical refactoring, so engineering refactorings. Of course, that's good to have as well, but my main request, or the most important for me, is to get everything conceptually and architecturally and design wise really solid and set in stone. And yeah, that's the first iteration at least, and then later, of course, we have to go over every single line and think about every single line. If there could be anything what breaks, if there could be any case where this line could cause a problem. Yeah, I have to implement the other proposal types, at least on a prototype level, that I'm sure that there will not be surprises. I also want to implement the bonding basics. So yeah, we use these bonding schemes for securing important roles, like the arbitrators. They need to put up a bond. They are locking up BSQ for undefined time, and then unlocking it at any time when they are stepping back as arbitrator, and any other roles in BSQ will be bonded as well. So that will probably not be part of the first release, but I would like to have as well the prototype implemented, that I'm sure that there will be no surprise when we implement it. And yeah, said there are not all details covered yet, and not many tests. I will start with tests and try to break anything as soon as the code is more or less really ready. The UI is very basic. I need more improvements. And yeah, the block explorer for BSQ, Kratzkoin has in the past already done a lot of work, but it needs some update with the current changes and with all the with the voting parts. And I talked with him already. He will be available to do it. So that should be done also in the next 1 or 2 months. As soon we are ready from our side with a code review, I would like to reach out to somebody like Peter Todd for external code review. And when we are ready for deployment, I would like to start first on testnet only, that we are doing our monthly compensation request now on maybe in parallel in Bisq, and have a kind of like a testing phase on testnet for 1 or 2 months, and maybe there will be even more extended deployment, slowly deployment of the full version, but has to be defined later. Yeah, here are a few links to references, the basic overview, the phase 0 document, and the technical specification. The technical specification is quite up to date, but as I said, it doesn't cover all the details. And as a clear disclaimer, I'm absolutely not interested and will not support anybody who is intending to make an alternative implementation. That would just carry a lot of risk and headache for me. And only the code is a specification for something like this. Nobody should create a BSQ transaction on their own. That's just looking for troubles, and any small mistake can render your BSQ invalid. And we will not help such people when somebody is doing this. Yeah, then he has burned his BSQ. There will not be a hard fork like in Ethereum when somebody make bugs here. And the technical specification only, yeah, it doesn't define all the details, like that there must not be multiple op returns or whatever, or other small details which are only defined in the code. So the code is only the real low-level specification. The tech spec is kind of like in between for non-developers to get the deeper understanding. And of course, the code, I'm working on a local branch on my repository, and it's not only in the Bisq core, it of course touches all the other projects as well, the peer-to-peer and the desktop. So you need to check out all the projects. Yeah, I think that's the last slide. Are there any questions?
Not from my side. I will dig into the documents and the code a little bit myself later on. For everyone who is watching us live, do you have any questions regarding what Manfred just presented? Just give it a couple of seconds because we have a delay also in the video stream. So for a timeline, Manfred, to do the testnet release, what do you think is realistically from the current point of view?
Yeah, it changes all the time. I hope at least that I'm getting kind of like ready for internal review in about 2 weeks. I mean, I'm traveling in 1 week, so I will lose a few days. But yeah, I'm already pretty close, but all the time there is something new, and I want to get really, don't want to make compromises here. I mean, the compromises are a little bit on the engineering side, and like with the threading and such stuff, made this compromise to use the single-threaded model to reduce the risks and make life easier. But I want to be 100% sure that on the consensus, on the critical parts, and on the basic design decisions, I'm basically in the state that I say I cannot make it better. That's the best what I can do. Then, of course, I'm happy to get input from you and from Chris and SQ and Naiman and anybody else who want to contribute in a deeper review. And maybe you find some flaws. Maybe we will do some changes. Yeah. Can be easily, of course, because it's quite complex and there might be some stuff that I've overlooked. And then, of course, on the engineering side, there can be done improvement on the architecture, and so, of course, always can be improved. Then for me, it's more important, the next most important thing is, yeah, to get really the tests, to make it really bulletproof, to try to break it with all kind of crazy transactions and all kind of crazy non-possible use cases from the UI, but when somebody wants to attack it on the code side. And at the same time, to implement the UI in a way that it's good enough. It will not be perfect UI because it's mainly for the contributors, not for the mainstream users. So it will not be super polished, but it should be clear enough, at least, that people can deal with it. And yeah, and do a lot of testing, and then we should be ready for the first version in the testnet.
Yeah, perfect. Thanks.
So maybe something like 6 weeks, 2 months might be realistic.
Mm-hmm. Yeah. So there are no other questions in the live chat. So I would say thank you very much, Manfred, for taking the time to walk us through the current state of the DAO and the implementation, and also the prototype as well. So if you're watching this recording and you have any suggestions, questions, please feel free to put it in the comments below or contact us on Slack or GitHub to talk it through. Yeah. Anything else, Manfred, from your side? Otherwise, I would close the call today.
No, I think that was more than enough. Thanks everybody for watching. I know it's pretty dense. I mean, it's not intended for casual listeners, only for developers or people who are already quite deep into the core of the Bisq and the Bisq DAO. And I'm super excited as it's really a super interesting and fantastic topic. And I just want to emphasize it's really 100% decentralized. There is no single element where, I mean, there might be such like these firewalls that I can send up blocking messages in the worst case that we can, But that was in Bitcoin with this global alert messages when something goes wrong, that you can stop it in a way. But beside this, the DAO itself is really 100% decentralized. It's in the hand of the stakeholders. They making the decision, and everything is done by the power of the blockchain in combination with our peer-to-peer network. And I think this combination is quite interesting, and it's a smart contract application. It executes the stuff which has been their intention, which have been expressed by the humans by voting, gets represented automatically in automated result, like new stake, new issuance, or changes of parameters. There is no direct human interaction there. I think it's pretty cool.
Yeah, absolutely. Yeah, it's really exciting stuff. So thanks again, Manfred, for presenting today, and thanks everyone for watching, and have a great weekend, and see you soon.
Yes, thank you. Bye-bye.